Hello everyone, today we are going to look at chapter 6, angles and tangents of circles. Over here we are just going to look at angles at the circumference. So before we enter the chapter, I would like you to recall back what you have learned in Form 2. Okay, in Form 2 you learn about the parts of circles, right? So I give you a circle over here. This part is the chord. This one is diameter. This one radius, and the black dot over here, that is the center of the circle. Okay, so you need to know all the property of the circle first, the chord, the diameter, the radius, and the center of the circle. Okay, next, this part here, this is the minor sector. This part here is the major sector, and then the line here is the major arc, and then the smaller one here is the minor arc. Okay, so major arc, major sector, minor sector. Okay, now we are going to look at angle at the circumference. What is angle at the circumference? The first thing that you need to know, it is the angle at the circumference. So you can see the angle here, angle PQR, this angle is the angle at the circumference, which is subtended by the arc PR. Okay, you need to know very well about the angle of the circumference because later on there will be a lot of questions that involve the angle at the circumference. To identify it, you just refer to the arc, and then from the end of the point of that two arc, there will be line pointing at the circumference. So this is the angle at the circumference. For example, I can build another one from P, from R, the same arc. So this is the angle at the circumference by arc PR. Okay, therefore for the first one there, we have angle PQR. This one is the angle at the circumference of the circle subtended by arc PR. Okay, we look at the next slide here. So we have a few angles, the one in pink and also the one in blue. Okay, we look at the one in pink first. This is the angle at the circumference. Okay, the angle PQS, this angle here, is the angle subtended by arc PS. Same with the angle PRS, this one is also the angle subtended by the arc PS. So as we can see, this arc is bigger, right? Therefore, it is a major arc. Okay. Then we look at the blue color angle over here. Okay. This is the angle subtended by arc QR. Okay, I use another color. I use blue. So arc QR here, we can see from arc QR, the angle subtended by arc QR is angle QPR, this one. And then from Q and from R, this is the angle subtended by arc QR. At the circumference, this is angle QSR. Okay, and you have to remember these two angles, they are the same. Why the same? We look at the next slide here. Angle at the circumference subtended by the same arc are equal. So we have arc PQ here. From arc PQ, we have three different angles subtended at the circumference, which is angle PRQ, this one, angle PSQ, and also angle PTQ. Therefore, you can do the what do you call it, the brainstorm in your textbook and find out is actually the same. So you just have to remember that angle subtended from the same arc at the circumference, they are having the same value. For example, if I say PRQ is 10 degree, therefore PSQ, PTQ will also have 10 degree each. Okay, same as when we look at the slide that we have just now. Angle PQS, this one, and angle PRS is the angle subtended by the major arc PS, right? Therefore, these two angles, they are the same. Okay, the same. Same with the blue color angle here, they are the same because they were subtended from the same minor arc. Okay, we look at the next slide. Is angle ADB equal to angle ACB? Angle ADB is this one, ACB is this one. Remember, we learned the angle at the circumference. If you look at angle ADB, is the angle here at the circumference? No, right? It is outside the circle already. Therefore, angle ADB and ACB is not the same. They are not the same. Okay? If you look at the second circle here, this one, same. Is angle ADB equal to angle ACB? No, right? Because the angle ADB here, it doesn't touch the circumference at all. Therefore, this one we cannot consider angle at the circumference. Okay, therefore angle ADB is not equal to angle ACB. Now we look at example 1 here. Based on the diagram on the right, calculate the value of y. Okay, if we look at angle ADE, this one here, it is outside the circle already, so it's not the angle at the circumference. We are not going to consider that anymore. Okay, now we look at y here. This is y. Angle y is also called angle ACE. It is subtended from the arc AE. So from this arc here, we also have another angle subtended at the circumference, which is angle ABE. Okay, remember angle subtended from the same arc at the circumference are the same. So if angle ABE is 40 degree, meaning that y is also equal to 40 degree. Therefore, y is equal to angle ABE equal to 40 degree. Okay, next. Now we look at this angle at the circumference subtended by the arc that are the same length are equal. So we can see here PRQ. The PQ, the arc, is the same as SU, right? So which means when they are the same, the angle at the circumference will also be the same. Meaning that this angle, if it is 20 degree, so angle STU, this one here, will also be 20 degree. Okay, now if we look at this one here, the size of the arc is different already. The size of an angle at the circumference subtended by an arc is proportional to the arc length. So if you look at arc SU here, if it is y centimeter, and then the angle subtended at the circumference is x, then you compare with the bigger size of the length of arc here. This is 3y. Okay, if it is 3 times y, the value of x will also be 3 times x. That will be proportional. For example, if I say this is 4y, then the angle at the circumference will be 4x. They are proportional. Okay? Now we look at the second example here. The diagram on the right shows a circle with length of arc PR equal to QS. Okay, PR equal to QS meaning that on the circle here, we can see, okay, PR is equal to QS. Can you see? P to R is equal to Q to S. Q to S here. Okay, determine the value of X and give reason for your answer. Remember, the angle subtended at the circumference from the same length of arc are equal. So if they said that PR is equal to QS, meaning that the angle will also be the same. If this is 40, the value of X will also be 40. Therefore, you can look at the solution here. X is equal to 40 degree because angle X and angle 40 degree are at the circumference, and the length of arc PR is equal to QS. Any problem? Okay, now we continue with example 3. Based on the diagram on the right, determine the value of X. So you're given the arc PQ here is subtended angle at the circumference with the value of 25. Okay, and the arc QR here is 6. How to get 6 meaning that it is 3 times the length of PQ, right? 3 times 2 equal to 6. Therefore, the value of X will also be 3 times X. Okay, or you can do it in the form of ratio like this. X over 25 degree, okay, is equal to 6 over 2 centimeter. Okay, when you simplified it, 2 times 1, 2, 2 times 3, 6. So to find the value of X, it will be 3 times 25. Therefore, the answer is 75. Okay, we look at the last example for today here. Example 4, given the length of minor arc PS is 2 times the length of arc QR. Okay, we have to look at the length of PS now. This is PS, P2S. Is twice the length of QR. This is QR. Okay, so PS is twice. They are still to determine the value of X. Where is the X? The X is over here. So before we find out the X, you are given that triangle PTS here is a isosceles triangle. When there are isosceles, if this is 48 degree, meaning that the angle of TPS over here is also 48 degree. So we have to find the angle of PTS here. To find PTS, it will be 180 degree because the total of the sum of angle of a triangle is 180, right? 180 minus 2 times 48 degree. So we will have that angle is equal to 84 over here. This angle is 84. 84, okay? So to find out the value of X, remember the length of arc PS. The arc PS is twice the length of arc QR. So to find out the value of X, it is equal to 84 divided by 2. Therefore, the value of X is 42. We can see here. Okay, so that's all for today. Thank you for being with me, and please share the video with your friend. Remember to do the exercise that I give to you. See you again.